1 from the homework. So the cosine of x is 1/3. That means its reciprocal secant will be 3 over 1, or simply 3. Let's also recognize that the tangent is less than 0, so the tangent is negative. If the tangent is negative, that means that sine and cosine have to have different signs. Because remember, tangent is achieved by taking sine over cosine. So if we get a negative answer, these are different signs. We already know that cosine is positive. That means sine, its reciprocal, must be negative. We are going to achieve this without drawing a triangle. So I'm given cosine. I go back to my trig identities, and I see I'm going to use the first trig identity. So I'm going to write down sine squared theta, or x, whatever you're going to use, plus cosine squared equals 1. I'm going to replace cosine with 1/3, and I'm going to write it down twice. Sine squared theta plus 1 times 1 is 1, 3 times 3 is 9. Now I'm going to move 1/9 to the opposite side, and so it's positive. When it moves over, it's going to become negative. And I want to combine these without using a calculator. So times 9 times 9, I have 9 over 9. 9 minus 1 is 8/9 equals sine squared x. So I'm going to take the square root. Normally we would say there's a plus or minus, but remember, we've already determined that sine is just going to be negative. So the sine of x is equal to negative the square root of 8 over the square root of 9. Now the square root of 9 is 3, but I need to rationalize 8. So I'm going to break it down to the square root of 4 times the square root of 2. So I have negative 2 radical 2 over 3. This is the sign. I'm going to go up top and do negative 2 radical 2 over 3. All right, now I need to take the reciprocal of this to get the cosecant. So I'm simply going to flip it. 3 is now in the numerator, negative 2 radical 2 is in the denominator. Multiplying by square root of 2, I get 3 radical 2. Now, this would be the square root of 4. Why am I doing this? Because we can't leave a radical in the denominator. Square root of 2 times the square root of 2 is the square root of 4. The square root of 4 is simply 2. 2 times negative 2 is negative 4. 3 square root of 2 over negative 4. 3 square root of 2 over negative 4. Students often wonder, where do we put the negative sign? As long as there's only one, it can be in the top, in the middle, or on the bottom. Tangent. There's more than one way to do this, but I want to do it the simplest way. Tangent is sine divided by cosine. I know the sine, and I know the cosine. So I'm going to write sine divided by cosine. My sine is negative 2 radical 2 over 3 divided by cosine, which is 1/3. When I divide, I'm going to flip the second fraction and turn it into multiplying. The 3's will be reduced. I end up with negative 2 radical 2 over 1, or simply negative 2 radical 2. How do I find the reciprocal of tangent? I'm going to write 1 over 2 radical 2. So this is equivalent to the cotangent for this problem, but I do need to put it in proper form. So I have radical 2 on top. This is equal to the square root of 4. The square root of 4 is equivalent to 2. So 2 times negative 2. 2 times negative 2 is negative 4. Oh, did I write that down wrong? I want to make sure I did this right. Hold on one second here. So this is square root of 2 over 4. So let's take a look at number 3. I've not done number 3 yet, but I do recognize that they're already trying to tell me what is going to be the symbol. So the signs on the different, both primary and secondary trig functions. So it's between pi over 2 and 3 pi over 2. So it's going to be in this range. It's going to be in this range, okay? And it says that it's going to be in this range here, and we know that the sign is positive. Well, if the sign is positive, and this is going to be located in either I'm sorry, guys. I'm so sorry. Let me go back to here. So it's either in quadrant 2 or quadrant 3. Because sine is positive, we know it has to be in quadrant 2, okay? If it's in quadrant 2, by the way, what's going to be the sine? Positive. What's going to be the cosine? Negative. What's going to be the tangent? Negative. All star trig class. All right, so I'm going to go ahead and I'm going to look at my trig identities, and I'm going to rely on the first one. So I'm going to do the sine. Right, let me move this down here. And so I'm going to replace, I know the sine is 5/13, but we have two of them, so 5 over 13 times 5 over 13. So that's 25 over 13 times 13 is 169. And now I'm going to move this to the opposite side because I want to isolate the cosine. I know I easily can turn 1 into the same value of 1 by writing it 1 over 69 over 1 over 69. Okay, can somebody take 169 minus 25 and tell me what you end up with? I think it's 144. Is that right? 144 over 169. We don't need to worry about going to a positive and a negative because we can see that the cosine is going to be negative. Square root of 144 is 12. Square root of 169 is 13. So this is what my cosine is. The cosine is equivalent to negative 12 over 13. So cosine is negative 12 over 13. Its reciprocal is negative 13 over 12. So, the sine is 5 over 13. The reciprocal is 13 over 5. And now I'm going to teach you a shortcut right now. When you know the sine and the cosine, and the provided values have the exact same denominators, all you're going to do is take the numerator of the top, because think of sine as going to be opposite over hypotenuse. If we think of this as a triangle, cosine is adjacent over hypotenuse. And so when you find the tangent, it's opposite over adjacent. So this is really just going to be 5 over 12 and 12 over 5. If that did not make sense to you, then think sine divided by cosine, because tangent is sine divided by cosine. So my sine is 5/13 divided by cosine negative 12/13. And then when I divide, I turn division into multiplying and flip the second fraction. I end up with negative 5 over 12 and the reciprocal. So now all I'm going to do is I'm going to look at 5, 7, and 9 just because they're on the paper. I just needed to manipulate this stuff. That's all I need to do. So, like for instance, I know cosecant is the same as 1 over sine. So I'm going to rewrite this as 1 over the sine of x. And I'll keep sine right there. Remember, it's like sine over 1. When I multiply, I get sine over sine. Or you could think of just reducing this ahead of time. You get 1 over 1, which is equivalent to 1. People in front of me, does that make sense? Okay. When I look at this, I want to go ahead and look at, okay, tangent squared minus secant squared. Okay, I see both of those trig functions in this identity. I'm going to write down this identity. Tangent squared plus 1 equals secant squared. So how can I rewrite this in this form? Well, I would need to take and move the secant to the left to make it tangent squared minus secant squared. So let's subtract secant squared to both sides. Now I have tangent squared minus secant squared plus 1 equals, and there's nothing left on the right-hand side. Okay, so all I want to have on one side of the equation is simply tangent squared minus secant squared. So I need to move this one to the opposite side. And I'm left with tangent squared minus secant squared. 0 minus 1 is negative 1. When I have this by itself, what is it equivalent to? It's equivalent to negative 1. Let's look down below. Okay, cosine, and I'm going to write it horizontally, divided by, now before I write down cotangent, what is cotangent equivalent to? Cotangent is equivalent to cosine over sine. Cosine over sine. And when we divide fractions, we turn division into multiplying, and we flip the second fraction. What happens to the cosines? Yeah, we say cancel out, but really we know they reduce down to 1, and what's the only thing I'm left with? The sine of theta.